All right, guys, we're going to go over our take-home quiz today. That's going to be the first part. Here we go. I didn't show this to you in class, but we're going to teach cheap shortcuts now. Grab your calculators. See that? Here we go. Now, it turns out you can enter stuff like this into your calculator, and it will tell you the answer right away. But it won't put down any of the work. Let's take a look at how to do that. Hit the y equals screen. Okay. What you're going to do is we're going to enter this equation into the y equals screen and take a look at what the answer should look like graphically. How do you get the absolute value markers? Where do you go and look for them? Yeah, we're going to go into the math section, number, ABS, and then you just, type in what's there, 6x minus 7, and close the brackets. All right. And now, does anybody remember where we get these symbols over here? Like, yeah, second test. Right here. Right? We're going to go and we're going to do the less than or equal to symbol. Oh, the test. Oh, I'm sorry. And then a 5. Now, once that's entered in, just hit the graph button. Let's see. That is what the answer looks like. Do you know what that means? Shoot. Well, you do have to make your graph bigger, but so what I'm trying to get at is that one reason people got this problem wrong is they told me that 2 numbers were the answer. But do you see how it gave a bar like that? The answer is not just 2 numbers, but rather an interval. You know? Oh, yeah, less than or equal to. That's what this symbol really means. It's going to be like a whole range of numbers. So now that you know kind of what the answer looks like, by the way, you could use this technique on your Regents exam or on my tests to try and spot out which multiple choice answer is the right answer without doing any work. Okay, it's where the short answers come that you're going to get screwed. But easy, easy. Okay, so that's kind of how to see it in the calculator. Before we switch over just to showing your work, let me show you one other thing. If you go into second and table, do you see how there's a whole bunch of like zeros and ones in that right category? It's trying to tell you the answer using binary notation. Binary, zeros and ones. It's how computers communicate. 0 means no, 1 means yes. That's all they can answer are yes and no questions. So here, the answer to this particular question lies between 0 and 3, is what it's trying to tell you, because that's where the numbers. You see, it's only registering whole numbers, but if I made the calculator like cut up those numbers, you'd start to see way more of them show up. Okay, now let's do the question. Now let's do this out like how most people would have done it. You break it up. You get 6x minus 7 is less than or equal to 5. Negative 6x minus 7 is less than or equal to 5. This, we're going to add 7 to both sides, so 6x is greater than 12, and x is going to be less than or equal to 2. And over here, there's all different ways. Do you want me to distribute it in, or do you want me to divide by -1 first? What's easy? Okay, we will distribute it in, and then you're going to get like negative 6x plus 7 less than or equal to 5. Negative 6x is less than or equal to -2. Whoops. Divide both sides by -6. X, flip the sign, is going to be equal to, what, a third? Most people can do that kind of work. True? All right, now, how do you write your answer? So people got here on their quiz, and then you know what they wrote? Here's where people went wrong. You can't write this. This is most common response on your quiz. When you use notation like that, like these kinds of brackets, these swirly things, it means just these 2 numbers are the answer. Let me show you what kind of brackets you could have used, right? Now, you could leave your answer like this. You could have written your answer, x is less than 2 but greater than 3. So you could have used soft brackets and done a third and 2. Wrong brackets. Sorry about that. Not soft brackets. Hard brackets because of the less than or equal to. Or if that's really confusing to you, maybe you just want to draw me a picture. I like that. Here's a third. Here's 2. It's got to be less than or equal to 2, but greater than a third. So colored in circles right here and here, and the line in between. All right. All right, number two. This one got a lot of people. How do you do something like this? What's up? There's one important factor that you have to do before you do any of those other factoring techniques. Close. Do you see this business? Actually, let me use this for a minute. Do you see how they're all out of order? You have to put them in order. Highest power descending downwards. So just move them around. Almost like, what's that game where, do you ever play text twist on your phones or things like that, where you shake it up? Or what about Scrabble, where you move all the letters around? Okay, good. So all we're going to do is move stuff around. This, and this are called terms. So we're going to move the terms around. Negative x cubed minus x squared plus 6x, because that's essentially a positive 6. And now we do our normal factoring. What's the GCF? It is x, but when you do these problems, you always want to have this number in front be a positive. So we're going to pull out a negative x. That's the GCF. Shoot, tell me.
How do you pull out negative x from positive 6?
Oh, watch. When you decide to say, okay, I gotta pull out a negative x, you're essentially kind of like dividing it out. So negative x cubed divided by negative x is x squared. This divided by negative x is going to be positive x. And this divided by negative x is going to be and after you write this, whatever you've written down should multiply back to be the original. If it doesn't, you messed up. So that's it, right? No? Why not? Jamie? Absolutely. Older, what were you going to say, girl? Okay? This right here gets factored more. And we're just going to keep negative x is going to tag along with it. All right? Here's negative x. Okay. Now talk to me. How do you factor something like this? Carly? Oh, you're going to do the AC method? We could do it that way. We could. Don't get me wrong. I love it. I love the suggestion. Jess? Carly? What do you think? The AC method works. It's kind of like takes more time, and it's used for when if there's a number in front, like let's just say there's a 3 over here. That's when you would really want to use it. Otherwise, you'll run out of time. Let's see. So it's going to be x plus 3 and x minus 2. And that's what your answer should be. Now, some people had some different versions of this, and I had to like look at it very carefully. You see, if this wasn't negative x, this was x, then one of these should technically be like, have a negative 1 still inside of it somewhere. Is that what you were going to say? The negative x doesn't just fade away. It's part of, like, factoring means like deconstructing. These are the 3 building blocks which produce that. So to just take away one of the blocks is to take away part of the structure itself. It's a different thing. When you have that equal sign, then there are different kinds of properties that you could use with it. But since there are no equal signs, you really can take nothing away. everything must still be there in the end. You know?
Okay. You put it in parentheses. And then do find the GCF. Wait, yeah. Oops, wait. No?
No, she said you're absolutely right, but you gotta keep going. You got one last thing to finish, right?
Oh, and then I know that's like a common square or something, but I don't know what to do.
What do you want to say?
Yeah, you gotta like I forget what it's called, but it's like you get 2x and then you get 3.
Minus 3 or plus 3?
Let me see what I got. It's minus 3, so it's negative 9.
Call on anybody you want. You're in charge, bro.
Okay.
For the difference, that's your perfect square.
And then 2x plus, is it this one? The same thing?
Well, you gotta do 1 of 2x plus 3 too.
What? Oh, right here?
There you go.
Okay. Oh, so you pull out x, and then you do x squared plus 5x, and then you take out the 4, and then you do x plus 5. Oh, thank you. This one?
Yeah.
Oh, wait, and then it's the same thing. Oh, so then you do x squared plus 4, and then x plus 5. Oh no, wait. X squared plus 4 plus x plus 5. Wait. Oh. X plus 2. Shh, don't tell me. X plus 2. No. X plus 5. Okay. You should. Oh no. I'm gonna do it in red because it's what I got wrong. Minus 4. 2. Oh.
There you go, Jamal. Why don't you go up there and help?
Oh, wait. Wait, it has to be minus.
Just take this all away. This is gonna be the answer, but this is gonna be plus 4 because you only break it down if it's negative 4 and it wasn't negative 4.
Wait, what?
This put a plus 4 like this. It stays. This is the answer.
I thought you said that if it's...
No, if it was a negative, then you broke it down again. But it wasn't a negative, it was a plus when it was here. So it stays like
Wait,
this.
didn't I have that positive like 5 minutes ago?
I don't know. That's the answer.
This is the answer.
Oh yeah, and there's no plus sign right here.
This is the answer.
All right. Problem number 5. What's the thought process? What do you do first? Okay. You're the man. Isolate the absolute value. Yeah. So you just divide both sides by 2. Ooh, a lot of people were doing that, which brings up the interesting point. There's no symbol between these, which means what operation is going on? Which means how do you undo it? By dividing, yeah. You could also say to yourself, 2 of these quantities is greater than 10. That means one of the quantities must be greater than 5. If it said 2 plus, then you would have been right. So many people did that, they subtracted it off. You know, and then you know the deal. Then it just works out like your normal thing. You break it up. Negative x plus 4 is greater than 5, and then like negative x plus 4 is greater than 5. No, I'll tell you what people did. So then we got negative x has got to be greater than 1, and x has to be greater than, oops, you got to flip the symbol because we're going to be dividing. Right, divide both sides by negative 1, x has to be less than negative 1. And then it's going to be like x minus 4 greater than 5, and then x has to be greater than 9. I think that's right. Yeah. Okay. Now here's what people did. They said, this is a negative number, I got to reject it. What do you think? No. Yeah. Don't do that. You could leave it like this. This is your answer. You could write that down. If you don't like doing that, you could have drawn a number line if you wanted to. X got to be greater than 9.
How do you know when to reject something? Like in a word problem, it's not
If it's you reject something if it doesn't make sense. In a word problem, that's true. Yeah. That should be your standard rule. If you could plug it back in and it makes sense, keep it. If it doesn't make sense, reject it. Even still with width and length, right? If you got a negative number and you plugged it back in and it produced a negative area, that makes no sense, reject that number. But if you got a negative number and you plugged it back in, right, and the whole thing made sense, like the negative number plugged back into an equation for width, that when you plugged it back in gave you a positive width, then it still makes sense to use that kind of number. But that would be your answer. Yet another way that you could do this, but a lot of people in here won't understand it, but I feel like I should show it to you, and then we're going to be done for today, don't worry, is you could say that it goes all the way to negative 1, but I don't think people will get this. What do you think? Is that hard? Is that craziness? Wow. Wow.